This video is about differentiation and how it can be used to calculate, first of all, the gradients of tangents and normals, and then equations of tangents and normals. Now, in these questions, I have got a sketch of some curves. You don't have to sketch any curves in these questions. This is just to help us to visualize what's happening. Now, this curve here is the curve y is equal to 2x squared minus 7x plus 3. And the question here in red, we want to find the gradient of the tangent at the point where x is equal to 2. So when x is equal to 2, this is the point that we're considering, and we're asked to find the gradient of the tangent at that point. So the tangent is this red line. We want to find the gradient of that tangent. So what we do is we differentiate the equation of the curve, 2x squared minus 7x plus 3. Therefore we get dy by dx is equal to 4x minus 7. Now this gives us the gradient of the curve at any x value. In this question, the x value is 2. So plug in 2 into our dy by dx. 4 2's are 8. Subtract 7. That gives us a value of 1. That means that the gradient of this tangent is 1. Now if we were asked for the gradient of the normal, we would do exactly the same thing, except just take the negative reciprocal of this 1. Because the tangent and the normal are perpendicular. Second example, here's our curve again. And that curve is y is equal to 2x squared minus 5x plus 3. This question is asking us to find where the gradient of the tangent is 7. So we're going to differentiate and let it equal to 7 so that we can come up with the x value that gives us that gradient. So we differentiate, we get 4x minus 5 is equal to 7. Solving that little equation gives us an x value of 3. What that means is, whenever x is equal to 3, that corresponding coordinate, the tangent at that point, gives a gradient of 7. So the actual coordinate then, the x value is 3. To figure out what the y value is, we plug our x value of 3 into our original curve. That is the original equation of the curve, 2x squared minus 5x plus 3. So the final answer is 3, 6. Next example is a cubic curve with a sketch here on the right. It's a cubic, you'll notice, because it has an x cubed term in it. Now we want to find where the gradient is equal to 4. So just like previously, we want to differentiate it and let it equal to 4. But differentiating gives us a quadratic. Now when we rearrange that, we can solve that quadratic, but you should know that quadratics have two solutions. The reason why there's two solutions here is because there's two x values that will give us a gradient of 4. So after differentiating, let it equal to 0, we can factorize and solve. So this quadratic just factorizes by taking out a common term, take out 6x. Then that means 6x is equal to 0, so one of our solutions is x is 0. Or the bracket here, x minus 1 is equal to 0, so the second solution is x is 1. So whenever x is 0 and whenever x is 1, on that curve we will get a gradient of 4. Let's find the corresponding y values by plugging x is 0 and x is 1 into our original curve. So plugging 0 into our original curve and plugging 1 into our original curve gives us the two coordinates. So these are the two coordinates on this curve that will give a gradient of a tangent of 4. Section B is now the next step. So after we know how to find the gradient of tangents and normals, we can then write an equation for either the tangent or the normal. Now remember that a tangent and a normal, they're just straight lines. Straight lines in the form y is equal to mx plus c. Now all we need to find the equation of a line is one coordinate and the gradient at that coordinate. So with an example here, a cubic example, cubic curve, because it has a cubed x term, we want first of all to find the equation of the tangent at 1, 4, and then just to keep it simple, we'll find the equation of the normal at that same point. So what we need is a gradient and a coordinate to come up with a straight line graph, the equation of a straight line, that is. So taking our equation and differentiating and plugging in our x value, because it's 1, 4, the x value is 1, plug that into our dy by dx, gives us an answer of 12. What that means is that the gradient of the tangent at this point 1, 4 is 12. This is therefore m in our y is equal to mx plus c. And like I said above, what we need for y is equal to mx plus c is m, x and y. Plug it into y is equal to mx plus c so that we can calculate or figure out what c is. So in this case, plugging in our x value of 1, our y value of 4, our m of 12 gives a c of minus 8. We can therefore write the equation of the tangent as y is equal to 12x minus 8, where 12 is the gradient and minus 8 is our y-intercept. Part B, it's the same point, the same coordinate. We're just looking at the equation of the normal now. Now the gradient of the tangent is 12, so the gradient of the normal is therefore the negative reciprocal, which is minus 1 over 12. And just like before, we need m, x and y, plug it into y is equal to mx plus c. This time we'll have a different c value and obviously a different m. So in this case, y is equal to mx plus c, where m is the negative reciprocal of the gradient of the tangent, and c is worked out by doing y is equal to mx plus c.